Balan 259473. Today I'm going to present about interlocking. As you can see here, interlocking stands for two different meaning, which means it's break into two. Inter stands for mutual, locking as known as a fastening. These two, interlocking, stands for, it's usually mechanical or relay based. In such interlocking system, the various routes and switches outside a station are physically connected together so that setting one route through the station automatically disables all other routes. It means once the signal are transmitted to the interlocking system it's switched on, so it will give the signal through the a small vibration. So once it's given that, so it will make the system to switch on, and the various routes and switches outside the station are physically connected and it will works. An arrangement of signals, points and appliance operated from a panel or lever frame or VDU. VDU stands for visual device unit. So interconnected by mechanical locking or electrical locking or both, that their operation must take place in a proper sequence to ensure safety. So when the signal are transmitted accordingly, then it will provide a proper sequence which will never cause accident or intermediate problem between the route. So the second thing, how it works. Interlocking allows trains to cross from one track to another using a turnout and a series of switches. As I told you, it is depends on the signal and it will be transmitted either manually or automatically. Railroad terminology defines the following types of interlocking as either complete or incomplete depending on the movement available. There are two types of category which is interlocking has been categorized. Firstly, you can see here complete interlocking allow continuous movement from any track on one side of the interlocking to another track on the opposite side without the use of a reverse move within the limits of interlocking. It means there's no reverse, only front, one direction. This is true even if there are differing number of track and opposing side, or if the interlocking have multiple sides. It may have multiple sides, it will change the track, but it have no reverse. As I told you earlier, only one direction. Secondly, incomplete interlocking do not allow such movement as described above. Movement in interlocking, incomplete interlocking may be limited or may even require reverse movement to achieve the desired route. So as you can see here, incomplete interlocking is totally opposite to the complete. It has the movement where we can control it. We can even go make it reverse or front or side. So it follows according to the system. Thirdly, I'm going to talk about types of interlocking. There are mainly three types of interlocking, as you can see here: mechanical interlocking, electromechanical interlocking, and relay interlocking. So I'll pass it to my another friend.
Mechanical interlocking. A locking bed is constructed and consisting of steel barriers of formatting grade. Mechanical interlocking provides a control of a railway area through the movement of the individual levers, physically connected by the wires and routes to the signal points level crossing gates or barriers, which means when you move the interlocking lever, you can change the railway, the train way from point A to point P. Okay. Okay, mechanical interlocking has a greater safety and less manpower. Mechanical interlocking using plungers and anti-barriers. When we say greater safety means when you move the levers, you only can move it in one way, as our friend Darwin said, and that's gonna ensure you cannot move another lever which gonna give them like same way, or they're gonna connect them to the same rail. And the other point is less manpower. That's mean one man can move, like can work in a station which can control more than 20 to 30 levers. Third point is when the lever is locked, it will come out. No, come back. When the lever is locked, it will come out of the notice and it becomes free again to use. as you can see in the photo, there is like a small notation. When you move the lever back to its place, it will come out, and you can change it to other lever. So you can change the other one. If it doesn't come out, the other lever will not work. Okay, the first mechanical interlocking was installed in 1843 in England, and they still use it until today. Next. Okay, electromechanical interlocking. It's kind of follow the same construction, but it just do it by power, which they mention here. Power interlocking might also use mechanical interlocking to ensure the suitable sequences of the levers. The lever is free to move based on the locking down. Connects on the lever actuate the switch and the signals, which is operated electrically. Here, as they mentioned here, the levers will just give a signal to the switch or whatever, so it can move electrically. Before the control lever may be moved into the position which is released other levers, a signal must be received from the field element that has actually moved into the position request. So means we cannot move the lever until the lever came back into its place. So the gate or the switch will come back to the same place as we leave it before.
Okay, good day everyone. Okay, so the next one is a relay interlocking. Okay, relay interlocking is purely electrically consist of complex circuitry made up of relay in arrangement of relay logic that ascertain the state of position of each signal appliance. Okay, relay interlocking usually used in a busy station that have to handle volume of train of movements. So relay interlocking is basically very famous in Indian Railway. Okay, so this interlocking relay interlocking is operated solely by electrical circuit and designed to operate without human operator. So it's relay interlocking is like an automatic interlocking. So it didn't no need to have a human operator to operate it. Okay, so this relay interlocking actually designed not only for the safe movement of the train, but also to speed up the operation of the train. And the final one is the entire route through the station can be selected, and all the associate points and signal along the route can be set at ons by a switch for retrieving, holding, blocking, and dispatching train. So relay interlocking is like just we need to have a switch that just we need to push or like we just press the button, so it will be do all the works. Okay, so the final one is the importance of interlocking system. So the first one is the of course for increase the speed of the route setting, and the interlocking allow train to cross from one track to another using turnout and series of switch. Another important things of interlocking system is to ensure that sectional route release does not happen due to an incorrect sequence of train, and also design so that impossible to display a signal to proceed the movement of the train is safe. So that's all from our group about the interlocking system. Thank you.
Thank you.